Hello everyone, welcome to our machine learning masterclass internship, and this is day 16. And in the past two sessions we have seen about algorithms, right? Theory behind it. And don't worry, today will be the final algorithm based theory sessions. Mostly we'll be completing in today's session, and the remaining session we'll be going with projects and hands-on, so it won't be that much theoretical. Just to learn the math behind it and how it works, we have to go through this. And yeah, we are inside of our day 16, and previously we have completed algorithms like linear regression, logistic regression, lasso, ridge, and also about decision trees, support vector machines. So shifting our focus towards today's part, we'll be discussing about ensemble techniques. We need to learn what is actually ensemble technique and what will happen in bagging and boosting. So we have some algorithms like random forest, and we have ADA boost, XG boost algorithms, etc. After that, we also need to learn about naive Bayes classifier algorithm and about k nearest neighbor algorithm. And if time permits, we'll see algorithms like for clustering, we need to see algorithm k means clustering. We'll see in this session or in tomorrow's session or the next session with our metrics and hyperparameter optimization techniques. Yeah. Starting with our day 16, we'll start with ensemble algorithms. So we have two types. We have a lot of ensemble algorithm types, but these are the two most prominent. One is bagging, another one is boosting, which is very often used nowadays. So if you talk about the algorithms, most of the people prefer to use XG boost algorithm or random forest based on their performance ability. So what is this difference? If I tell you random forest is nothing but it is a collection of tree based algorithm, which is decision tree. Random forest uses decision tree only. Okay. So if you're talking about XG boost, it uses decision tree, or you can have some other algorithm. You can select the algorithm, base algorithm. So it's actually a concept. It's an ensemble learning. So what does this ensemble algorithm means? Ensemble algorithms in machine learning are techniques that combine the prediction of multiple individual models. So these are called as base model or weak learners to improve the overall performance and accuracy of a predictive model. So which means that in ensemble algorithm, we don't have one model, which means that we have one model which is like a decision tree, something like that. But it's not like only one time, it is going to repeat multiple times. Okay, multiple individual models will be ran inside, and their prediction will be taken into account, okay, to improve the overall performance and accuracy. For example, instead of going with one decision tree, if you go with 100 different decision trees, okay, and based on from that 100, if you take output, that will be really good, right? So each one will contribute. Or imagine, what if one decision tree performs and like 100 decision tree together they perform? That's actually good, right? So there are certain methods like how this 100 is going to work, whether they work on the same data, what's the difference there? That is coming under this ensemble types. Ensemble method are powerful because they can reduce overfitting, okay, because of result from different algorithms. Many algorithms are giving their output, so they can reduce overfitting. They can improve model generalization, not only for your training data. If you give test data or a new set of data, it should perform well, right? So that will come in the model generalization from ensemble algorithms, and it enhances the predictive performance compared to the single model method. And we have two types, right? Starting with our bagging algorithm. So bagging algorithm, bagging the name, it's actually simple definition or simple meaning. Bagging involves creating multiple bags, okay, or multiple bootstrap samples, randomly selected subsets with replacement from the training data, and training a separate base model on each sample. So in bagging algorithm, for example, we have algorithm. Imagine a base algorithm. It can be decision tree. If you are having 1000 row of your data, so that data is split into random bags. Okay, for example, split it into 10 bags with 10 randomly selected rows. So each bag will be now having 100, and that will be replaced also. Not only that, it will be shuffled also inside. And then these individual things are given to individual algorithms. Create 10 algorithms inside 10 decision trees. That will happen in bagging. That's what bagging is, separating your data set into bags of data, splitting them into subsets with replacement, which means they will be shuffled in between. So the prediction from these models are combined totally. Okay, for example, if you have one set of 100 values, Okay, that will define some value for that algorithm. Next time, a different shuffle will be given to the next algorithm. So it is going to be intershuffled. So their data combination will also change. Finally, all these 10 will give some prediction for all these 1000 rows. So the prediction from these models are combined. Okay, and you need only one output, right, which is yes or no, or if it's a classification or regression, a value. So for classification problem, what they will do is they will do voting, which means if you have two classes yes and no, and for one question out of these 10 algorithms, how many is given? For example, if 7 is given as yes and 3 is given as no, based on the voting we have the output which is yes. That's will be the output. And if it's a regression, then if there are 10 algorithms and 10 are giving 10 values, average will be taken, so that will be your final output. So that is what happening in your bagging based algorithms. And one of the popular used bagging algorithm is nothing but random forest. It is a popular ensemble algorithm that uses bagging technique with decision tree as its base model. So you have multiple decision trees, and collecting all these trees is called as forest, right? Collection of trees, a lot of trees is forest, and it's a randomly picked bag, so it is given a name as random forest. Let us see about random forest algorithm. It's again a bagging algorithm, and random forest is a popular machine learning which is used for both classification as well as regression task, which works best on both of these. And it is an ensemble learning method that combines multiple decision trees to create more robust and accurate final output. So the random forest algorithm works by building a large number of decision trees, each using a randomly selected subset of the available input features and a randomly selected subset of the training data. So it will be randomly selected, picked, and these decision trees given with different data are then combined to make prediction on new data by taking a vote or average, and the output will be that. Okay, so if it's a classification, then you are going to take vote of who is the majority, and if it's a regression, you are going to take the average of it and give the result. So this is how a decision tree combined random forest work. Data set is splitted into parts and given to different decision trees. You know how a decision tree works. We have seen it in the previous session elaborately. That will happen, and this guy will give a result, this guy will give a result, and this one will give a result. Based on it, if it's classification, then voting will happen. If it's a regression, then average will be taken and the final output is given. So that's how a random forest algorithm works. And if you want to use it, you can take it from sklearn.ensemble package. You can import random forest classifier as well as random forest regressor, and here this algorithm perform well in both. So it's actually a good task, and yeah, we'll go and from sklearn.ensemble import random forest classifier, and from sklearn.ensemble import random forest regressor. So you can create objects and use it. You also have a lot of parameters to define. You can search that in the documentation. We will see it in the next class about hyperparameter optimization. So that is what about random forest algorithm. They don't particularly use any max behind it, which means like they don't have any separate field. They are just going to randomly pick your data points, split it to your data decision tree. So they have some max, they'll do the statistics and give the result. So the only thing happening here is this majority voting or average, and finally the output will be given. And that's all about our random forest algorithm. Next, going into our boosting algorithms, we have seen about bagging algorithm, right? So in boosting, we have a lot like ADA boost, XG boost, CAT boost, gradient boost, etc. We'll see two important algorithms here. One is ADA boost and another one is XG boost, which are most popular now, which is preferred by a lot of people. So the boosting algorithm, what they'll do is, imagine, see here, one is bagging. So we are splitting it into bags. So boosting means improving the performance, right? Boost is like giving a boost. Okay. So boosting focuses on improving the performance of weak learners by giving more weight to instances that are difficult to classify correctly. Which means that what is weak learner? Weak learner is your base learner. Like this also uses algorithm like decision tree can be used, or any other algorithm can be fixed here. That's fine. So boosting focuses on improving the performance of weak learners by giving more weight or importance to instances that are difficult to classify correctly. I'll tell you how it works. First time one model will be selected and it will be given the data set. This algorithm will be having the original and predicted answer, right? It itself learned and it itself gives a test for it. So based on the output from it, it will decide how much is correct and how much is wrong from the original answer. And it should decide if it goes wrong, what all points gone wrong, it will take that, and next time another model will be created where this wrong things are given more weightage. So it will learn more on these wrong things and the correct things will be coming correct, so that by the end, after a sequence, it can give a lot of correct answers by reducing the number of wrong answers. It's like, for example, in an exam, if you know you are weak in a subject, what you will do? You will give more importance to that subject and learn, right? So if you fail in that in your midterms, what you will do? For your final exams, you will give more importance to that subject. Like that, it will improve. That is what boosting algorithms. So for every time, one model will be created and it is improved frequently. So in boosting, base models are trained sequentially. Okay, it's not parallelly giving, separating like bagging. It is sequence. So one model done, then the next model based on your previous model result. And each subsequent model pays more attention to that instance that were misclassified by the previous models. Based on the wrong output, that will be given as a feedback to the next one. And common boosting algorithms include AdaBoost algorithm, gradient boosting, which includes gradient boosting comes under XG, extreme gradient boost, light GBM, cat boost, and adaptive boosting like AdaBoost. We'll see about XG boost and AdaBoost here. First, we'll start with AdaBoost, which is adaptive boosting. So AdaBoost algorithm, which is short for adaptive boosting, is a boosting technique used as an ensemble method in machine learning. It is called adaptive boosting as the weight are reassigned to each instance. So this will actually follow that definition, which means that with higher weight assigned to incorrectly classified instances. For the wrong answers, every time it is going to assign further more weight. Okay, more importance to it. So the basic idea behind AdaBoost is to iteratively train weak classifier on different subset of the training data. It also creates subsets of the training data too, and assign higher weights to the sample that were misclassified by previous weak classifiers. In this way, subsequently, the subsequent weak classifier focus more on difficult samples that were not correctly classified by your previous classifiers. So this is how it will work. You are having a model 1, your original data set will be passed. So it will make some prediction. So based on it, the updated weight, wherever it is wrong, it will be corrected and it will be given that these are some wrong answers from your side, previous model, please improve it. That will be given to model 2 and it will be once again making predictions. From that, what all things wrong will be given here, like that iteration will happen. So it assigns the higher weight to wrong classified observation, so that the next iteration, these observations will get high probability for classification. So if you want to use AdaBoost, you can go from sklearn.ensemble, import AdaBoost classifier, and from Ensemble you can also import AdaBoost regressor. Once again, it is going to just do the same classification and regression from algorithms like baseline or like a decision tree, or you can choose that. And let us go and use it from sklearn.ensemble, import AdaBoost classifier, and you can import in the same line, no issues, AdaBoost regressor. So we'll see about these two. I just want to show you about this Ensemble, sklearn AdaBoost classifier. We'll just see that first. Okay, so what is happening here, we can see the estimators and the number of estimators, how much it is going to be, how much time it is going to iterate, what is the algorithm which is used in the backend. So those things will be given here. You can actually choose what is the base learner you are going to set, that also can be selected. So that's how your AdaBoost will be working. Fine, so these are some of the hyperparameters which we'll be dealing later. So there is actually a common methods to do this. Yeah, so also you can go with sklearn random forest classifier. You'll see the documentation. Yeah, this is the documentation of it, and these are some of the criteria which we can alter. We'll see that in the hyperparameter optimization. And see here, the decision trees have been used here as the base estimator is going to be decision tree here, and you have options to select them too. So we'll see that further. Okay, so that's it about our ADA boost and all. Going with the next one, which is XGBoost, the last we are going to see in our Ensemble algorithms. Talking about XGBoost is extreme gradient boost. Works by, it is algorithm, it works by building a series of decision trees in a gradient boosting framework. This also use decision tree, you can use other algorithms too. So what this will do is, in this framework, each tree is built to correct the error of the previous tree. That we know, that is what ADA boost is also doing, right? But what is the uniqueness of this is, okay, the final prediction will be the sum of the predictions or based on the voting or average, that is fine. I'll tell you how it works in the next slide. Before that, one of the important feature of XGBoost is it has the ability to handle missing data. You can have null values in your data. If you can't handle anything, you can go with XGBoost, which can work with missing data, and XGBoost can automatically learn how to handle missing data by assigning different directions in the tree to the missing values. How to use it properly, XGBoost knows, they will take care of it. XGBoost also comes with the option of GPU. If you have GPU, then you can enable it, it will work much more faster. And see here, these algorithms are going to use many algorithms inside, so it is going to be computationally time and energy will be taken for this XGBoost and other Ensemble algorithms. So how this works, what's the difference from the other algorithm is, XGBoost uses a gradient based optimization approach to minimize the specified objective function, which typically includes a loss term to measure the difference between the prediction and true one. So it will find the loss term, and based on how much loss, what is the difference between your predicted and the original one. For example, if you have an algorithm, okay, first time it has a decision tree, XGBoost has a decision tree, it will train, it will get the result, it will compare with the original result. Previously what happened is, what are misclassified in ADA boost, that has given more weightage. But in XGBoost what will happen is, what is the difference between your original and predicted one, that value will be given more weightage, so that to reduce the loss it will work. So XGBoost also incorporate L1, which is lasso regression, and L2, which is regularization terms to control overfitting also. So that's all about our XGBoost. See here from the residual from this, what all the difference in your cost function or loss function, what's the loss that will be given here, so that it can improve and reduce the loss. So that's what the idea behind our XGBoost. And you can go with pip, and see here it is not available in your sklearn. If you want to use it, you can install using pip, install XGBoost, and from XGBoost you can import XGB classifier, and you can also import XGB regressor. So I'll go with pip install XGBoost. If you have it, it will be telling you requirement already satisfied. Since I have it, if you don't have it, it will install, and from XGBoost you can import XGB classifier as well as XGB regressor. See here the capital terms. Okay, so you also have XGB random forest enabled, so that will be XGB RF classifier and regressor. Okay, so that and all additionals from your XGBoost. So this is actually a good algorithm which is used by a lot of professionals. You can create an object and use it. So we'll focus to our next algorithm. So we'll continue with our next algorithm, which is going to be naive Bayes. So let us start with naive Bayes. Naive Bayes is actually for classifier. It's a classifier and it can be used for classification purpose. And naive Bayes is a classification technique that is based on a theorem, which is Bayes theorem, with an assumption that all the features that predict the target variable are independent of each other. So this guy is a little bit tricky. So that's why the name is naive, okay, which is unique, something like that. What the other algorithm uses is, what they used to do is, they will be considering all the features. Okay, they will try to interrelate and then try to fix the output, which is like if you have given 5 columns. So based on all the values, which considering all the 5 columns, the output will be predicted, the target. But what this is doing is, naive Bayes Okay, it is for classification and it is based on the Bayes theorem, which gives an assumption. And what does that is, all the features that predicts the target value are independent of each other. So if you have 5 features, so each of them are independent of each other. So everyone will contribute individually. So their value or their relation will be calculated individually, and then finally based on that output will be selected, whether it can be a class like either this class or that class can be selected from that, since it's a classification kind of problem. And it calculates, what does that do in the math? Okay, it calculates the probability of each class. Okay, first it will calculate the probability and then pick the one with the highest probability. So who is having the highest probability, that will be picked. Simple. So based on probability it will work, and it has been successfully used for many purposes in classification with your data, but this is particularly well performed with natural language processing problems. So later when we discuss about NLP, we will use this naive Bayes classifier for classification problems. When you have your text data, NLP is nothing but natural language processing. It is actually a field, we will be seeing about it later. Remember about the introduction class we have discussed about ChatGPT or chatbot or sentiment analysis from your text, etc. Right? So those comes under natural language processing, and we'll be using a library specifically for it, which is nothing but a natural language toolkit, which is NLTK. And we'll also get the support from sklearn to choose algorithms, where we'll be using naive Bayes. We'll use it later when we see those projects with NLP. Yeah. So finally, when I talk to you about the naive Bayes, it is nothing but it has an assumption that all the features that predict the target variable are independent of each other, and it calculates the probability of each class. How much probable? For example, if you go for a probability, one common example is heads and tails. So if you go with heads or tails, what will be the output, whether it can be head or tail? So we can calculate the probability, right? So the total number of occurrences by number of time it came, etc. And then with that, based on the highest probable, either yes or no or heads or tail, which has the highest probable, the naive Bayes will give you the output. So the naive Bayes classifier assumes that the features we use to predict the target are independent and they do not have any relation and they do not affect each other, while in a real data, features depend on each other in determining the target. But this is ignored in the naive Bayes classifier. When we talk about any other algorithm, see, remember, we have used some other algorithms, right, for classification or regression. We used single data and multiple columns can also be used, and they will be interlinked. Okay, but here that is ignored because that's what the assumption is. We used to predict the target and which are independent and do not affect each other. Okay. Yeah, so moving with the next one, this is the formula or the math behind your naive Bayes classifier, which is the probability of your output is going to be based on this formula. So the calculating the posterior probability from the likelihood of your prior probabilities of probability of y and probability of x. With that, if you calculate this value, so that will be your output. And with that, okay, this is for your single feature. So yeah, you will be having multiple features, right? So it will be calculated individually. You can see your output with your y value. For x, it's like if you have 4 columns, then the value will be x1, x2, x3 and x4. Till how many feature you have, that many will be calculated and used here, divided by, so the probability of x1, x2 and so on. So this will be calculated individually for every feature, so which confirms the assumption, right? So here we want to consider everyone as independent and they do not affect each other. So they gave separate importance and their output is taken. For example, this is one of the text-based data. In NLP, what I'll tell you in short, what we used to do is, once again, NLP is also coming under, it's a natural language processing, but there also you are having data. So that data is in the text format. We will be using some methods to convert this text into numbers. With that numbers, once again, we are going to use machine learning. And see here, this is a data set simple example for naive Bayes classifier. We are having a sentence, okay, so like the text which are included in the spam mails. Do you know what is a spam mail? Spam is nothing but the fishy mails which you get, okay, which are not proper, or you can tell it as unwanted content. Just to someone try to get your informations, they can send some spam mail. You can even have a spam folder in your mail, right? So how they are classifying it based on the past data, like this, okay? And not spam words, we are having a data set. So in a sentence which is not spam, the dear is used 8 times, so that is in the probability of not spam. But dear is also used in spam sentences in 3 times. So like that, visit, invitation, link, etc. You can see the word, it is not common in the not spam. It is mostly in spam. This is not we used to tell it as ham or spam. Ham means normal mail and spam means spam mail. So like that, you can see the discount, money, etc. will come into the spam. Okay, so the total number of words in not spam is 34, and if you want to find the probability, you can divide that value by the total occurrence, which is 34, and the value for your spam is going to be 47 total count, and you can count that too. Okay, well, with that we will be calculating probability. So with this, what we will be doing is, if you go with naive Bayes classifier, so that guy will calculate the probability. You can see, for example, this is just for first 4. See here, dear, whether it's not spam, you get a value. How will you get it? 8 divided by 34 is the probability for the dear to get into not spam. So for the dear word to get into spam, the probability will be 3 divided by 47. Why? Here 3 divided by 47. Like that for visit, for next till dinner, you will be calculating. It will be calculated in the backend. Okay, and so on till the end, it will be calculated. So finally, if I am going to predict, okay, so this is the data training part. So when I give a new sentence for prediction, for example, I am giving a word which is hello friend. So hello friend is now should be calculated. Okay, first it is going with not spam and trying to find a hello friend. So now if you go with this hello friend, it is splitting it into hello and friend. Okay, so now testing it for not spam. Okay, so it will go into the data set and try to find what is the probability in your data set. Okay, so if you find that probability, see here the probability for your so this is the reverse case, the hello and friend and the not spam probability total. Okay, so you go with 5 divided by 34. Why? Because hello, you can check 5 divided by 34, and then 6 divided by 34 is from friend, okay, of going into not spam, and the total 15 divided by 25. So when you totally sum it, the probability of not spam is from your total. How many words is there? Okay, in that how many is not spam words? So if you go with that, the total will be a value which is here we got around 0.0155. Now this same procedure should be followed for words, okay, for spam words. Okay, so going with that, you need to go and calculate it. When you go with hello friend, so you need to find hello is how many times in the spam. Okay, and yeah, hello is how many times in the not spam. You need to calculate that. See here, this is 4, and we are having our friend here. Yeah, so with that, what will happen is it is going to calculate for your spam what is the probability. So this is 15 by 25, and here it is 10 by 25. The remaining 10 is here. So if you totally calculate it, this value is going to be around 0.00072. So who is the majority here? It is the probability majority is for not spam. So that will be selected. So your output is, it's not a spam. So like that, if you calculate and you see the next one, see here, this is another example we are having. So the task or sentence is dear, visit, dinner, money, money, money. So it looks like a spam, we can even tell it, but how will a computer is going to classify, how machine learning is going to classify. So the formula for this is to take the probability and multiply it with the total spam, and we can see that we are having for this money, okay, dear, visit, dinner, money, money, money. So we need to see it from here. So from that, what will happen is in dinner we are having the spam value which is 0. So when you calculate actually the spam for it, the entire thing goes down to 0. Okay, so which that mean what will happen? So does that mean that it is not a spam but it is actually a spam? That is actually an issue. So why this happened is because the word dinner does not appear in the spam data set. So hence the probability will have no effect. This is called a zero frequency problem. And to avoid this, what you can do is there is something happening behind also to avoid this task, which is Laplace smoothing. So the Laplace smoothing is a technique for smoothing categorical data. So what will happen is a small value will get added, a pseudo count or a constant is get added, so that your total won't be going into zero. So it is constantly added to everyone. So it can't be becoming zero, and they can contribute individually others. So talking about that, we are adding, see here, this 1 by 10 is going to be like a constant value. So you are calculating for spam, and you can find if you calculate for not spam, you can get the value, and comparing that, now it can be determined as a spam message. So that's how naive Bayes classifier works, with the help of our Laplace smoothing to avoid that issue, and based on the probability, okay, based on this particular value, so that will be done. Okay, so continuing with the next one. Yeah, so we'll see about the types of naive Bayes now. So it has 3 types. We are not going into that deeper. We'll be seeing when we see about the NLP task, then only you can understand. So first one is Gaussian naive Bayes. So this classifier assumes that the features follow a Gaussian distribution. Once again, you know how to find a Gaussian distribution. If it has a bell-shaped curve, it is suitable for continuous data. Also, if you have text data, if your data is continuous, where each feature can be modeled as a continuous variable, Gaussian naive Bayes works very well for problems like text classification with continuous valued features. And when you go for this multinomial naive Bayes, it is specifically designed for discrete data such as text data, and it's commonly used in NLP tasks such as text classification and spam email detection. So in multinomial naive Bayes, each feature represents the frequency of a term in a document. We also have something known as TF-IDF, which we'll discuss later, which is term frequency, how much the term appearing in the entire document. So TF-IDF is a different one, which is term frequency and inverse document frequency. And going into the Bernoulli naive Bayes, it is another version, okay, suited for binary data where features are either represent as present or absent. And it is commonly used in document classification task, where each feature represents the presence or absence of a term in a document. So it can also be used in spam detection. Mostly naive Bayes is for text-based task. So moving into the next algorithm, which is going to be K nearest neighbors. We have already seen this guy in our imputation technique, right? So we'll see a little more elaborately about how it works here. Starting with K nearest neighbor, or KNN algorithm, is a type of supervised machine learning which can be used for both classification as well as regression predictive problems. The KNN algorithm compares a new data. Okay, if you are passing a new data entry to the value in a given data set, okay, so how will it give answer is based on the closeness or similarity in a given range of K value, the algorithm assigns the new data to a class or category in the data set. So first you will be giving your training data to your algorithm, fine, it will learn. And then if you will need to set a K value, it can be like 5 or 10 or 30 you can give. So for example, let us keep it to 3 now. So what will happen is if you pass a new point, what it will do is it will try to find the 3 closest point in your data set, okay. So based on the K value, your new value, it will compare with 3 closest point, and what is their output? It is going to be your new points output. It is that much simple. See here, this is how it works. Graphical representation. First point is look at the data. This is the new data. Fine. Calculate their distance. This guy is closer, or this one is closer, this one is closer. And what you need to do is you will be setting a neighbor value, right? For example, if you set it as the first 4, the first neighbor, what is the distance? Second neighbor, what is the distance? Third, what is the distance? And fourth, what is the distance? So now it is going to take a vote here. So in the voting, we can see this color wins because this is 2 times here. So these are the closest neighbor, which defines that this guy belongs to their group. Simply that's how your K nearest neighbor algorithm works. Another representation, see here, we have 2 classes, one is red, another one is blue. And once again, if you have regression, you know how it will do. Think about our imputation, it also uses the same task. What it have done? So if you set 3 neighbors, then it will take the output of 3 neighbors and take an average of it and store it, right? So that is what happened here also. For example, here we have a classification kind of task where we have two categories, one is red, another one is blue. And going towards it, if you have a new point which is green, you can see near to it we are having two red color and one blue color, and based on the k value you have set it will try to find who it is. You can see it has been assigned as red because we have the k values which are near, so that is assigned to red color group. So that's how you can see, right? So that's how your k nearest neighbor algorithm works. So for example, let us have another detailed example. See here, this table, you have the brightness and the saturation level to find the color, which is red, blue and red. Yeah, totally we are having two classes, red and blue, like this. So we are having column like brightness and saturation. First let us assume the k value as 5. I am setting it to 5. So now what formula it uses is, I'll tell you before that I want to make a prediction. See here, these are the brightness I am having. If my brightness is 20 and saturation is 35, what will be the class of it? Brightness 20 and saturation is 35, what will be the class of it? So it uses a formula. See here, square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So where x2 is the new entry's brightness, which is going to be 20, and x1 is the existing entry's brightness, and y2 is going to be the new entry's saturation, and y1 will be the existing entry's saturation. So what we need to do is we need to calculate the value for all the points. Okay, so this will be used to calculate the distance. For example, if you set this is existing, it will try to find how many you have set it, that many neighbors will be taken into account, and you can find the distance. See here, for this point the distance is 10, and for this point the distance is 25. This is like, it is arranged in ascending order. It has been changed and arranged in ascending order based on the distance from smallest to larger distance. So now since the value of k is 5, the first 5 has been selected. 1, 2, 3, 4 and 5 has been selected. So in that you need to take a vote now. Who is majority, red or blue? Here red is majority, right? So red will be taken as the answer. So the output will be red. So you can see the new point has been given as red. So you understand how it works. This is what the formula. So x2 will be the new entry's brightness, which is 20, and y2 will be the new entry's saturation, and this formula is applied here. Okay, so with that we can go and proceed further and find the distance, and based on it we can calculate their value. Okay, for example, if you wonder what is this existing entry's brightness, so this is new entry's brightness, which is 20. Okay, imagine this is the existing. For if you want to calculate for this guy, then the existing brightness is 10. So you will be subtracting it and taking the square, plus y2 minus y1, which is 35, minus our saturation here. So you will take a square root of it. Your output is going to be 10 here. Okay, like that you will be calculating for others also. So that is what your x2, which is 20 and 35, will be constant here. This value will change for one by one. First time the value of this is going to be this guy 10, and saturation y1 will be this 25. Like that for everyone you will be calculating it. You will be plotting the distance. So the k value, if you go with 3, then consider in 3 also we are getting red, right? Based on that we will be predicting the output. Yeah. So going with the next one, see here, this distance we are calculating, right? I haven't told you about that. The formula and the distance we are calculating is called as Euclidean distance. The name of it is called as Euclidean distance. And practically the steps in KNN is select the number of k and calculate the Euclidean distance for all the points, and based on the k value, the nearest neighbor calculated from the Euclidean distance, select them. Among these k neighbors, count the number of data points in each category, assign the new data point with voting, or if it's a regression you can go with average. Finally your model is ready, right? And actually I have seen one new thing which is actually good. If you're in a real-time scenario, when we use it, we'll try this, okay, in KNN. How will you find which k value is best? That is actually a good question, right? So for that, what one guy does is, I have read it in a blog, and you can see what he does it. He used a for loop. Okay, see here, this is how you will take k nearest classifier or regressor from sklearn.neighbors. You will import k nearest classifier, k neighbor classifier, or k neighbor regressor, and you need to pass your neighbor value. That's fine. So what he done is, here you will be passing your neighbor value, right? So he is using a for loop from 1 to 40, and in this I will carry from 1 to 40, right? So every time the loop runs, he is creating a model, fitting it, predicting it, and calculating the error. Okay, the error I'll be telling you in the next class about the metrics, etc. He is calculating the error, which is the original and the predicted difference. So that error, what he is doing is, he is plotting for every k value once it is done. Every time the loop runs for 1 to 40, he is calculated the error value. So your task is reduce the error, right? So he is finding that the value error is very low when he reaches the point which is 37. When his k value is 37, the value of error is minimum, which means that is actually really good. So once he used this, what he does it, he set the value of 37 and predicted the answer. That is actually really good. We can also try like that. And this is also, you have to use your skills on your data analysis also by passing it like this. Okay, he is just plotting using plt.plot, right? And he is having some colors and dashed line, which is giving us the best k value. You can also do something like this. So in this session, we have covered a lot of algorithms, starting from ensemble algorithm, bagging in that random forest. Then in boosting, we have seen about ADA boost and extreme gradient boost, which is XG boost, and then focusing towards naive Bayes for NLP, and then shifting towards k nearest neighbor algorithm. We have seen those. Okay, so we have completed till now. We have covered a lot of supervised learning algorithm. So next session, which is day 17, we'll be seeing about starting with one of unsupervised learning algorithm, which is k-means clustering algorithm. And after that, we'll be seeing about hyperparameter optimization tools like grid search CV and randomized search CV. And after that, we will also learn for all these classification or regression types, what is the metrics, how to calculate the accuracy or the performance of the model. Once we complete that in day 17, in day 18 onwards, we can see projects. So we'll see there. Thank you.